Hello everyone. I am explaining assignment 2 parts, decision tree for COVID-19 prediction and pandas data manipulation. I'll show you my code, explain choices, and connect to class concepts. So first of all, part A requires a CSV with at least uh, 3 features and 30 rows for COVID-19 prediction. I use data from an NPJ digital medicine research paper. So I used actual values such as ages, temperatures, and cough severity scores. So this gives the decision tree better information than binary 0, 1 data. So now let's load and prepare data. So let's import all the libraries. And now pandas. Mm, and also let's prepare a dataset. Read CSV loads the CSV into a data frame. This is the foundation. Proper data loading is the first step in any machine learning pipeline. So now let's move to feature selection. Let's select 3 features such as uh, age, temperature, and cough severity. X contains features, the input variables the model learns from. Double brackets create a data frame with multiple columns. Y is the target variable, or what we are predicting. I chose this because age is a known risk factor, temperature indicates fever, and cough severity shows respiratory symptoms. Together, they provide different perspectives. This is feature selection, choosing relevant predictors. So let's launch it. Uh, Train test split. So also train test split randomly divides the data into 4 parts: X train and Y train for learning, X test and Y test for evaluation. Test size is equal to 0.3, means 30% for testing. Random state is equal to 42, sets the random seed for reproducibility, same split every run. Testing on unseen data verifies the model learned patterns, not just memorized training data. This prevents overfitting. So try training the decision tree, create and train the decision tree. Decision tree classifier creates the model object, feed trains it on X train and Y train. This is where learning happens. Makes predictions on X tests. Accuracy score compares predictions to actual values, calculating correct predictions divided by total. Using default settings, the tree finds optimal splits using information gain. It builds a tree by asking questions like temperature above 37.5 and splitting data accordingly. This is the decision tree algorithm. It creates interpretable rules. So let's launch it as well. In part B, we cover 14 pandas tasks. I'll walk through the key ones. So the first one is deleting columns. So delete the model column. Drop or remove specific columns. Model is the column name. Axis is equal to 1 means columns. Axis is equal to 0 would be rows. The assignment updates the data frame. Verify by checking the columns or shape. So task 2 and 3, cleaning and converting data. String accesses string methods. Replace finds the first argument and replaces with the second. Empty strings removes it. Regex is equal to false, treats brackets as literal characters. Node regex patterns as type int converts the entire column to integers. Real data is messy. Data cleaning is essential processing. Task 4, aggregations. Calculate average cost and average cost per continent. Mean calculates the average of the cost column. Group by is or groups rows by continent values. Then cost means calculate mean for each group. This returns a series with consonant as index and mean calls as values, essential for category comparisons. In task 5, we're doing visualization, create a bar chart of mean numerical columns by continent. Select D types, find columns with numeric data types. Columns to list converts to a list. The if statement removes ID since it's just an identifier. Group by groups by continent, then mean calculates average for all numeric columns. Plot creates the visualization, kind is equal to bar, specifies the bar charts. Fixed size sets dimensions. Visualizations reveal patterns quickly. So as you can see, it's also working properly. Now let's move to the task 6 and 7, value analysis, count continent occurrences and find unique values. So value counts returns value counts returns a series with counts of each unique value, sorted by frequency descending. Unique returns a non-binary of all distinct values in the column, no duplicates. Essential exploration tools for understanding data distribution. In task 8, we understand in value counts. Value counts how many times each cost value appears. Returns a series where index is the unique cost values and the values are the counts. Automatically sorted from most frequent to least, useful for identifying most common values and spotting patterns. So in task 9, we're doing histograms. Hist creates so Hist creates a histogram. Beans is equal to 50 divides the data range into 50 intervals. When more beans show more detail. Fixed size is equal to 6 to 10 and 6. Sets width and height in inches. Histograms reveal data distribution normal, skewed, or bimodal. 50 beans provide detailed shape. So here is our histogram. So in task 10 and 11, we're searching missing values. So find missing values, then drop rows with any missing data. Uh, is none returns true for missing values, false otherwise, sum counts true values, total missing in that column. Is null is an alias for isna. Dropner removes rows containing any non-values. Len counts rows. Missing data is common. Check first, then handle it. Here I drop rows by imputation is an alternative. So in task 12, we were doing data imputation. Field missing values instead of dropping, show statistics, then imputate. Describe uh, describe include all show statistics for all data types, including categorical. Value counts drop x equal false, includes none in the count. Fill replace all non-values with XXX string. This is imputation and alternative to dropping the preserves rows. So let's launch it. Okay, in task 13, we are doing descriptive statistics. Use describe for summary statistics, then access specific values. So describe calculates summary statistics, count, mean, STD, mean 25th percentile, median 75th percentile marks, returns a data frame. This gets the count value for the third numerical column. And in task 14, we're doing uh, sorting. Value counts automatically, sorts by frequency descending. Sort index sorts the series by its index values alphabetically. Different orders serve different purposes. Frequency shows most common. Alphabetical is easier to read. So thank you for your attention. That's all for my assignment demonstration. Goodbye.